Hello, grade 12 students. Mr. Yoon here with another video for Calculus 12. Today I wanted to make a video on the chain rule. And the chain rule is another rule that we're going to be using to calculate the derivatives of certain functions. So far in this chapter, I've talked to you guys about the power rule, the product rule, the quotient rule, and today we're going to talk about the chain rule. Now, if you want to use the chain rule, basically that means we're going to be trying to find the derivative of composite functions. Okay, so whenever we have a composite function, and if we want to find its derivative, then we need to use the chain rule. Now, if you forgot what a composite function was, basically here it is highlighted in yellow here. Usually when you have a constant function, you have two separate functions like f of x and g of x. And basically a composite function tells you to take one of those functions and put it into the other function. Alright, so let's take a look at the chain rule here. So the chain rule states that if you want to take the derivative, so d by dx means you want to take the derivative of this composite function right here, so f of g of x, that's a composite function. So if you want to take the derivative of a composite function, what you have to do is you need to take the derivative of f of x. Well, here it says f prime of g of x. Basically what that means is you need to take the derivative of your outside function, and then you need to multiply that by the derivative of the inside function. So this is your inside function, and this is your outside function. Okay, so when you have a composite function, just by looking at it, you can definitely tell that there are two functions involved, and usually it's not too hard to identify the outside function and as well as the inside function. And I'll work through a few examples where I talk about the outside and the inside function, and I'm sure that once you see a few examples, it'll be all good review. Now, sometimes when you have other calculus textbooks, like to use a different kind of notation when you're dealing with the chain rule. So if you want to take the derivative of y with respect to x for a composite function, certain textbooks will use a notation similar to what you see here. I have dy by du times du by dx. So you're probably wondering what dy and du and dx, what those symbols mean, and I'll try to I'll try to go over this notation in one of my first examples of this lesson, okay? So yeah, the goal for today's lesson is we're going to be trying to take the derivative of composite functions, and we're going to use something called the chain rule. And I do believe the chain rule is one of the, it might be one of the more harder rules, but it's also a rule that helps you, finish questions off pretty quickly if you're looking for the derivative of a composite function. So there are these questions are a little bit more challenging, but they're also kind of fun too because you do practice the other derivative rules as well. So let's kind of jump into the chain rule by looking at a simple example first. If I have f of x equals to 2x plus 3 all to the power 2, I'm going to take the derivative of f of x without using the chain rule. And I'm also going to find its derivative by using the chain rule. Okay, so here we go. Here's a good review question to start off today's lesson here. So I know f of x equals to bracket 2x plus 3 all squared. Now, if I want to find the derivative of f of x without using the chain rule and just using the knowledge that I have so far, some students may go ahead and just expand this. So this might be 2x plus 3 times 2x plus 3. This is f of x here. Then after that, you would go ahead and FOIL this. So you would take your 2x and times that by your 2x, and you would get 4x squared plus 6x plus 6x plus 9. And you'll notice that if you add the 6 x's together here, you'll get plus 12x. Okay, so I mean, this is nothing new. This is something that we've seen a lot in other math classes. So I just expand my polynomial there. Now, once I've expanded my polynomial, I can definitely find the derivative by just using the power rule. So f prime of x is going to be 12x plus, sorry, a little mistake here. The derivative here will be 8x plus 12. Okay, so there's my derivative for this polynomial if I don't use the chain rule. Okay, so what I'm going to do next here is I'm going to find the derivative of f of x equals to 2x plus 3 all squared by using the chain rule. Now, what does the chain rule state? It pretty much states that you want to take the derivative of your outside function and you want to times it by the derivative of the inside function. Alright, so before we apply the chain rule here, let's go ahead and identify the outside and the inside functions here. Now, if you look at this 2 here, and if you look at this 2x plus 3, the 2x plus 3, this is going to be your inside function. And your outside function is, well, you don't see it right now, but since you have a 2 out here, this probably means, well, it does mean that your outside function is going to be a quadratic. So it could be x squared, for example. So let's just say x squared equals to g of x, and let's say your inside function is f of x. Okay, so if I rewrite this here, this would be g of x equals to x squared, and your f of x function would be 2x plus 3. Now, if you treated this as a composite function, for example, g of f of x, would you not agree that if you take this function here, this 2x plus 3, which is this part right here, and if you inserted that back into your quadratic, would you not agree that you would get your polynomial of 2x plus 3 all to the power 2? I would say so, so you could definitely try that if you don't see it, but the outside function in this example is just going to be x to the power of 2. Okay, so basically if you want to use the chain rule here, you want to take the derivative of the outside function first and times it by the derivative of the inside. Okay, so let's go ahead and apply this, and let's just see how the chain rule works here. It's not too bad. Let me just delete all this. Now, if I'm trying to find the derivative of this just by using the chain rule right away, you need to recognize that this 2 here, that exponent there, that's part of your outside function. Now, if you take the derivative of the outside function, this is the same thing as just applying the power rule. So this would be 2 bracket onto 2x plus 3 all to the power of 2 minus 1, and 2 minus 1 is simply just going to be 1. And usually when you have something to the power 1, you generally don't have to write anything, so I'm just going to delete this and just state that by applying the power rule I would get this derivative right here. So these two 2's are the same. This is what I would have if I applied the power rule. Okay, so now that I've taken the derivative of the outside function, I now have to take the derivative of the inside function, and the inside function is this part right here, 2x plus 3. Now, what's the derivative of 2x plus 3? Well, it's just 2. Okay, so the derivative of 2x plus 3 is just 2. Now, if you multiply this out, if you take my two 2's and multiply them together, you get 4. And that would be 2x plus 3. And if you distribute this right through, this would be 8x plus 12. And you'll notice that we do get the same answers, right? These are exactly the same answers. All I did was for part B is I applied the chain rule, and I was able to get the answer maybe a little bit faster without expanding my polynomial. Okay, so before I continue, let me just kind of redo this example one more time so that we have an idea of how to apply the chain rule here. Okay, so basically, once again, I'll do this really quickly now. This was 2x plus 3 squared. Applying the chain rule, you just need to take the derivative of your outside function, and you need to recognize that the outside function involves this power of 2. And once you take the derivative of the outside function, you recognize that you need to apply the power rule here, so bring the 2 in front. The bracket stays the same. 2 to the power of minus 1, that would finish the power rule right here. So everything highlighted in blue there is just applying the power rule. And then after you apply the power rule, you just want to take the derivative of the inside guy. And the derivative of that inside guy we can probably do in our head because we're just using the power rule again, and that's just going to be 2. And then finally this would be 4 times 2x plus 3, and that would be okay for a final answer. Okay, so before I go on with the other examples in this lesson, I just want to go back here and kind of explain to you guys the notation that's being used here because sometimes, like I said, if you look at other calculus textbooks, certain calculus textbooks will use this kind of notation right here. So I want to take some time now and explain how this notation works, and I'm going to rewrite that just below here. So let me just kind of erase this all again. And you know, you don't have to write this in your notes, because when I do the example problems in this lesson, I won't be using this notation at all. I'm just going to be going right into how to solve the problems. But I just want to show you the notation that's commonly used in other textbooks here. So the notation that was being used above was dy by dx. So this means you want to take the derivative of y with respect to x. And I believe it was dy by du times du by dx. Okay, and let's just say for simplicity that our question is just 2x plus 3 squared. Okay. Now what's happening with these kind of questions is that what you can do is you can identify the inside function, and the inside function here is 2x plus 3. And what we do when we're using the notation that's being used in the textbooks is that you have to assign the inside function a certain letter, and that letter will be u. So I can let u equal to 2x plus 3. Okay, that's u right there. Okay, now if I wanted to take the derivative of u, alright, so du means I want to take the derivative of u, but since I have an x in my equation here, I need to take the derivative of u with respect to x. Now if I take the derivative of 2x plus 3, well, that derivative is just 2. Okay, so du by dx is equal to 2. Now, if I know that this inside function here has been assigned the letter u, I can rewrite this as y equals to u to the power of 2. And if I wanted to find the derivative of y here now, dy means I'm taking the derivative with respect to, well, since there's a u here, I need to take the derivative with respect to u here. And I just apply my power rule here. This would be 2u. Okay, so let me just kind of highlight these two boxes right here. This is dy by du equals to 2u. And I also have this box over here, which is du by dx equals to 2. Now, if I go back to my my notation that's being given to me, you know, right from the get-go here, if I focus my attention to dy by du, well, what's dy by du? Well, dy by du is simply just this guy right here, which is just 2u. So let me just delete this guy, and let me replace that with just 2u. Okay, and then ask yourselves what is du by dx? Well, du by dx is right here. It's just the number 2 there. So I can erase this du by dx and just put in the number 2 here. Okay. Alright, so let me just kind of delete all this now so that I have a little bit of space to work with. Erase that, erase that. That's good enough. So right now I have 2u times 2, and if I take the two 2's, this 2 and that 2, if I multiply them together, I get 4u. And then what is u? Well, u is right here. U is this 2x plus 3, so this would be 4 times 2x plus 3. If you multiply that out, you get 8x plus 12, which is the same answer as what we had in the previous problems. Alright, so there's a notation right there for the chain rule. There are some fancy notations that are being used, but I probably won't be using this kind of notation all the time. I'll probably just solve the questions directly, but I wanted to give you guys like kind of like a preview of what you will see next year, because next year they will definitely give you guys a lot of this heavy-duty math notation, and I'm just trying my best to kind of simplify what the math notation means. Okay, so now that you've kind of seen the notation for the chain rule, let's just go ahead and work on a few problems here. The first problem I have here is I want to differentiate this y equals to bracket 2x minus the square root of x all to the power of 2. Now, hopefully you can recognize that this question here is basically, you know, it's a composite function here because you do have this outside exponent 2, and then you also have this inside guy, which is 2x minus square root of x. Okay. Now, before you do this kind of a problem, I recommend rewriting any square roots as not as square roots, but let's just change all the radicals to powers. So this would be the same thing as y equals to bracket 2x minus x to the power of 1/2, close bracket, all to the power of 2. Okay, and there's my 2 highlighted in yellow. So before we start this problem, let's just change this radical right here in red into a power, which is x to the power of 1/2. Alright, so now that we've changed the radical, let's go right ahead and take the derivative. So if I want to take the derivative, I can say y prime. And using the power rule, I would bring this exponent 2 here to the front. So that would be 2 bracket 2x minus x to the power of 1/2, close bracket, and this would be 2 minus 1, and 2 minus 1 is simply going to be 1, and if we have an exponent as 1, we generally don't write that down. So let's just write this as 2x times 2x minus x to the power of 1/2. Alright, so now that we've applied the derivative to the outside function, now we just need to take the derivative of the inside function, which is highlighted here in yellow. Now, how do you take the derivative of the inside function? Well, what's the derivative of this 2x? Well, the derivative of 2x is just 2, minus, what's the derivative of x to the power of 1/2? Well, apply the power rule. So that will give you 1/2 x to the power of negative 1/2, close bracket, and then you're done. Okay. Now, before we finish off this problem, it's generally good practice to just simplify the problem here. So this is the same thing as 2 times 2x minus x to the 1/2. And what I'm going to do next is I'm just going to simplify, this part right here, the power, the 1/2s here, and that's just simply going to be 2 minus 1 over 2 root x. Okay. So the final thing I would recommend on that problem is just simplify the problem as much as you can, and then that will be your final answer. Alright, let's move on to the next example here. Okay, so the next examples here, these aren't too bad. We can definitely do these in one step if you know how to use the power rule. If you know how to use the chain rule, you can definitely do these next few problems in one step. So let's go ahead right here. Notice that you have an exponent 10 there, so that probably tells you that you want to apply the power rule here. So this is f prime of x. If you apply the power rule, that 10 comes out to the front, and then everything on the inside here stays the same. And the power rule states that you need to subtract the exponent by 1, so this will give you an exponent of 9 now. And then all you have to do now is you want to take the derivative of your inside function, which is highlighted here in blue. The derivative of that we can do in our head. That's going to be 4x cubed plus 18x squared plus 2. And the derivative of 3 is simply going to be 0. So I can close my bracket off there. And that is our final answer right there. Okay, so that one's done. Question number B. As mentioned in the previous problem, whenever you have these radical signs, it's probably in your best interest to rewrite those in terms of an exponent. So this would be bracket 2x plus 3 to the power of 1/2. Alright, so now we can take the derivative. Now I'm just going to change up the notation a little bit here. I'm going to say dy by dx. And once again, I see a power here, so that probably means that I need to do the power rule first. So this will be 1/2 times 2x plus 3 to the power of negative 1/2. Alright, so there's the power rule there in action. And the chain rule tells us that we just need to take the derivative of the inside function. So the derivative of the inside guy is simply just going to be 2. Okay, and now it's generally good practice to simplify this problem as much as possible. So if I highlight this 2 right here in yellow and this 2 here on denominator, those 2 will cancel out. And this will simply just give you 1 over the square root of 2x plus 3. Okay, so that's your final answer for that problem. I'm just changing this negative exponent, this negative 1/2 to a positive exponent. And sorry, if I change that to a positive exponent, I'm rewriting it as a radical on the denominator there. So sorry, it's not a positive exponent, it's just the radical sign. Okay, let's move on to question number C now. Now for question number C, this question will take a few steps here because you have to recognize what's happening. Notice that I have one function on highlighted in yellow, and I also have another function here highlighted in blue. So basically, before you can apply the chain rule, you need to apply the product rule first. Okay, so it's been a few lessons since we've seen the product rule, so let me go ahead and apply the product rule first for you. So this is y prime. This means that when we're applying the product rule, that means that we need to take the derivative of the function highlighted in yellow first. So I'm going to write this as 3x to the power of 4 prime, and then we're just going to times it by the 4x minus 1 cubed plus, and then I need the derivative of the function highlighted in blue. So this would be cubed. I'll put a big bracket there and put a prime there, and then I just need to multiply that by the yellow function, which is 3x to the power of 4. Okay, so that's the product rule right there. And let's go ahead and do the product rule first, because that one is not too bad, but eventually you'll see that you need to apply the chain rule later on here. So if I want to take the derivative of 3x to the power of 4, that's going to be 12x cubed, and then I'm going to times that by the 4x minus 1 cubed. Okay, and then I need to carry down my plus sign, and then I need to take the derivative of this guy right here, 4x minus 1 all to the power of 3. And you'll notice that this is probably going to be a combination of the power rule and the quotient rule. So first things first, I see a 3 here, so let's bring the 3 down in front. Bracket 4x minus 1 to the power of 2 times the derivative of the inside, and the derivative of the inside is simply going to be 4 times the 3x to the power of 4. Okay. And once again, we want to do our best to simplify the problem here. So what I see here is if I focus on, towards the right hand side of the equation here, if I highlight this 3 right there, this 4, and that 3, if I multiply those all together, I'll get 36. So let me just go ahead and rewrite this. This will be a 12x cubed times 4x minus 1 cubed plus 36x to the power of 4 times 4x minus 1 squared. Okay, and you'll notice that you can simplify this a little bit more. I mean, I have this 4x minus 1, I have a 4x minus 1, so I can factor that out, but I can also factor out this 12x cubed. Okay, so 12x cubed and this 36x to the power of 4, those all have a common factor, so let's go ahead and just factor out the greatest common factor here, which is 12x cubed times 4x minus 1 squared. Now if I factor that out here, I will be left with 4x minus 1, put that in a bracket, plus, this is just 3x, yeah, 3x. And yeah, that would be it. This would be an acceptable answer, and I'll probably give you full marks for that. Okay, let's move on to the next question here, question number D. Alright, so with question number D, you're probably thinking that, hey, I have an f of x on the numerator and I have a g of x on the denominator, so that probably means I need to use the quotient rule first. So we're going to definitely apply the quotient rule first to find the derivative, and then somewhere in there we're probably going to have to apply the chain rule. Okay, so let's go ahead and let's just apply the quotient rule first. Okay, so the quotient rule states that I need to take the derivative of the numerator first. So what's the derivative of the numerator highlighted in yellow there? Well, that's simply going to be 2 times x plus 1 to the power 1 and times by the 1 here. So this 1 here is simply the derivative of x plus 1. So if you take the derivative of x plus 1, and once you apply the chain rule here, you just get a 1 there. Okay, so that's the derivative of the numerator, and then I need to multiply by the denominator, which is just x cubed minus 2 to the power of 2. Okay. Alright, and then the quotient rule says that I need to have a minus sign, and then I need to take the derivative of the denominator here, which is highlighted in green. So how do I take the derivative of that? Well, we're applying the chain rule here and the power rule. So if I apply the power rule first, I would get a 2 times x to the power 3 minus 2, and the exponent would just be 1. And then I would have to take the derivative of the inside guy, which is simply going to be 3x squared. All right, and then I need to multiply by the numerator, which is x plus 1 all squared. Okay, so that's the quotient rule for the numerator, and then I'm going to divide this all by the bottom all squared. Now be careful, because the denominator has a power of 2 here already, but you still need to square the whole thing again, because that is the quotient rule, right? So the quotient rule tells you that you really need to square the whole denominator. Alright, so there we go. We've applied our derivative rules. The next thing that we have to do now is we need to apply our algebra rules and just simplify the problem here. Okay, so if I simplify this, this will be 2 times x plus 1 times x cubed minus 2 all squared. Okay, then I can minus okay, what do I see here? I can minus, let's just say minus 6x squared times x cubed minus 2 times x plus 1 all squared divided by, now if you're not sure on how I got this 6x squared here, all I did was I grabbed this 2 there and that 3x squared. I just multiplied those together and brought that to the front to get 6x squared. And the denominator is simply going to be x cubed minus 2 to the power of 4. So all you have to do here is just take your 2's and multiply them together, and you'll get 4. Okay. Other than that, the only thing that I can see from the numerator is you can go ahead and factor out this x minus 1, because you have an x minus 1 there, and sorry, an x plus 1 here and an x plus 1 over there. And you could also go ahead and maybe factor out the 2 there. Okay, so I can definitely factor out this 2 here, and if I look at that 6 here, I can probably do something there as well. So let's go ahead and just factor out a 2 and the x plus 1. If I do that, I will get x cubed minus 2 to the power of 2 here minus, I guess that's going to be a 3x squared onto x cubed minus 2 onto x plus 1 all over x cubed minus 2 to the power of 4. And okay, actually I do notice one more thing that we could do here. If you look at this expression right here highlighted in yellow here, you can definitely factor all those out. And if you factor all those out, oh, I should have done that right from the get-go here. That would have saved me some problems here. Okay, so let me think if I can rewrite this. So it'll be 2 times x plus 1. Now if I cancel out x cubed minus 2 from everything that's highlighted in the yellow boxes there, I'm simply just going to be left with bracket x cubed minus 2 minus 3x squared times x plus 1. So you'll notice that this whole thing can cancel off, that will cancel off, and this will cancel off to be a 3. And then I'll close that bracket off, all divided by just x cubed minus 2 to the power of 3. And this right here, I'm going to stop here. I mean, you can definitely go ahead and simplify this a little bit more, but this is good enough for me. You could definitely expand. If you wanted to go ahead and expand the inside here, you could probably simplify this a little bit more, but I'm not going to. I'm just going to leave that as my final answer. That is an acceptable answer for me. Okay, now that that's done, let me move on to the next examples here. Okay, so here I have another example where I have a quotient rule situation because I have a numerator and a denominator there. So let me just kind of get ready for this question right here. The first thing you want to do is you want to apply the power rule. So here's the cube here. So if you apply the power rule there, that's simply going to be 3 bracket onto everything on the inside, root x plus 5 all over root x plus 1 to the power of 2. So that's the power rule right there. And then we need to apply the quotient rule, and the quotient rule states that we need to take the derivative of the inside guy here. Now this is really going to suck because this is going to require a lot of work because we need to apply the quotient rule again. Okay? So let's go ahead and just take the derivative of, that fractional expression there, the inside function there, and just remember, if I have a root x here, root x is the same thing as x to the power of 1/2, and I know I have to take the derivative of the radical here, so if I write this in terms of power and take the derivative, this will be 1/2 x to the power of -1/2. So we're definitely going to have to use this rule here when we're taking the derivative of that inside function. Alright, so I know it sucks, but hey, you know what? You're going to see this on a test or a quiz, so let's just go ahead and find the derivative of that inside function now. Okay, so if I take the derivative of the numerator here, the derivative of this radical here, square root of x, is going to be 1/2 x to the power of -1/2. And then I need to times that by the denominator, which is just root x plus 1. Quotient rule says I need a minus sign next, and then I need the derivative of the denominator, which is also going to be 1/2 x to the power of -1/2, times by the numerator, which is going to be the square root of x plus 5. Close that off, another bracket there, all divided by the denominator squared, which is going to be root x plus 1 all squared. Okay. Alright, so let's just go ahead and simplify this. One thing I'm going to do right now is I'm just going to delete this expression right here. I'm going to rewrite that as 1 over 2 root x. And I'm going to go ahead and delete this expression over here, which is going to be 1 over 2 root x. And if I wanted to simplify this, hopefully you can see that I can factor out these two expressions right here, highlighted in yellow. So if I rewrite this, this will be 3 times root x plus 5 all over root x plus 1 all squared. I factor out the 1 over 2 root x. And if I do that, sorry, I'm going to write this a little bit bigger here. Let me just factor out the 1 over the 2 root x. And that's going to be highlighted here in yellow. And once I do that, I'm going to get root x plus 1 minus bracket root x plus 5 all over root x plus 1 squared, close the bracket. Okay. And you know what? I definitely can simplify this a little bit more. You definitely can. You can definitely get yourself a nicer answer, but I'm just thinking of how much time do I really want to put into simplifying this. Okay, so hold on. I can take, well, this root x right here in blue and that root x, they'll cancel out, and you'd be left with -4 on the numerator. So on the numerator here, you would get -4 all over root x plus 1 all squared. Okay, and then I'll bring, so if I take this 1 and that 3, if I multiply all that together and bring, if I just bring this guy out to the front now, I would get 3 over 2 root x times root x plus 5 all over root x plus 1 all squared times that. That's looking pretty good. And then from here on, if you look at this -4 here, this 3 and that 2, you can definitely simplify all those constants there. So if I take that 3 and times it by the -4, I get -12, and -12 divided by 2. So if you multiply all those blue numbers there, you would get an easier answer here. So let me just kind of delete that and continue here. I believe you get -6, and then that would be root x plus 5. Oh my goodness, what am I doing here? Okay, let me think here. Okay, let me put this over root x plus 1. Okay, so all of this will be square. Okay, sorry, this is just looking pretty ugly now. Sorry, negative root 6, and let's just do this. Root x plus 5 all over root x plus 1. All of this squared times by 1 over this root x plus 1 squared there. And I'm trying to think if we can simplify this any more. We probably can. Let me just think about it. So what I'm going to do here is I'm just going to combine this 2 and that 2 there, because if I get rid of the brackets here, I mean, this is the same thing as that squared and that squared, and this would simply give me negative 6 times root x plus 5 squared divided by root x plus 1 all to the power of 4. Okay, so I think that is how you would simplify this question. And one thing that I did forget was this green root x. So if I put that green root x just to kind of finish out the problem here, let's put that root x over here. And that would be your final answer here. So I do apologize. This one did take me a little bit more time to simplify. And I'm pretty sure there's going to be a few questions, a few students will be asking me how much do I really need to simplify, and I'll try to give a better answer to that question next time, because the reality is when you're doing your homework, your textbook will have an answer similar to what you see in the green box, but even if you can get the question down to like here, do a little bit of simplification, that'll probably take an ugly answer like that, as long as I can see that you are able to apply the quotient rule and the chain rule correctly. Okay, so sorry, that question was very long and very brutal, but you do have a few questions that are very long and very brutal when you're doing your homework in terms of simplifying. All right. I've got a few more questions to go, but this next example here is another hard example because you have a square root inside a square root, and to top it off you have this power of 3 there, which is just really, really annoying. But yeah, these are definitely some good questions and questions that will make you think. So let's go ahead and get this problem started here. The first thing I would do is I would take all your square root signs. Anytime you see a square root sign, I would change that to the power of 1/2. So let's go ahead and do that. Well, first of all, everything is being raised to the power of 3, and then I have this 2x squared guy here. So let me just write this 2x squared minus bracket 3x squared minus 4x. Sorry, let me just delete this. This is going to be all to the power of 1/2. And then the whole thing will be raised to the power of 1/2. And then finally the whole thing is being cubed. Okay, so that's step number 1. You want to get rid of all the radical signs and change them into powers of 1/2. And then if you apply your exponent rules, you'll notice that this 3 and that 1/2, you're able to actually multiply those together. And if I do that, I get 3 over 2. So let me just delete this now and give you a 3 over 2 here. Okay, so I was just using my power rules there, and I can get 3 over 2. Now I can't multiply this 3 over 2 and this 1/2 anymore. Okay, I can't multiply those guys because this 1/2 here is only applying to this part of the problem. Okay, so I can't times the 3 over 2 and the 1/2. That's not a proper exponent rule. Okay, but once I've simplified the problem now let's go ahead and find its derivative. So y prime tells you I need to apply the power rule first, so this will be 3 over 2, which is just this exponent right there. Okay, and then if I go ahead, this will be a 2x squared minus bracket 3x squared minus 4x to the power of 1/2 to the power of, if I take this 3 over 2 and minus 1 from that, I'll get 1/2. Okay, and then the chain rule tells you that you need to take the derivative of this inside guy now. Okay, so let's take the derivative of that inside guy now. So that's going to give you 4x. Whoops. This will give you 4x. And if I take the derivative of this guy here, well, I got to apply the power rule again. So that's going to be negative 1/2 bracket 3x squared minus 4x to the power of negative 1/2. Sorry. To the power of negative 1/2. Okay. And then once again, we should try our best to simplify this problem as much as possible. Actually, sorry, I made a mistake here. I still haven't finished the problem here. Let me just delete this last bracket there. I forgot to apply the power rule, sorry, the chain rule one more time. I now have to take the derivative of this inside function, and that's going to give you 6x minus 4, close the bracket, and then close another bracket here. I'll change that to a big bracket. Okay. So there it is. That's how you would differentiate this kind of a problem here. And I do apologize. I did make a mistake there at the beginning, but hopefully I was able to correct. I corrected myself, and hopefully you guys can follow the steps there. If you can't follow it, ask Connor on what's happening, or Kale, or Lucas, or Mac. All right. So. Last thing I need to do here is I want to simplify this problem as much as I can, and this is going to be a little bit difficult here. Let me start with this part of the problem first. Let me see if I can simplify that. Okay, so this is going to be 3/2. Now, if I put my square root signs back in, this would be the square root of 2x squared minus the square root of 3x squared minus 4x. Okay. I'm going to put that in a bracket there because I'm going to multiply that with this whole thing now, highlighted in yellow, and that's not going to look very nice, but this is going to be 4x minus, okay, this is going to be interesting here. Okay, let's put the 6x minus 4 on the top, divided by 2 times the square root of 3x squared minus 4x. And then close that bracket off. And the last thing you could do is you have a 2 here, a 6 there, and a negative 4 there. I mean, you could reduce those, but I'm not going to because I'm too lazy. So this is a final answer for this problem right here after I've done as much simplifying as possible. All right, so we're almost on the lesson here. I just have a few more questions to go, and then we're kind of finished here. We've finished most of the hardcore algebra problems. The last thing I want to go over are some of these other questions where you have other symbols in here, like f of x or g of x. So we should be able to find the derivative of these guys, and these guys should be a little bit easier here. So if I want to find the derivative of this guy right here, I'm going to write y prime. I see an exponent here. Let's apply the power rule here. So that'll be 5 times f of x to the power of 4, and then I need to take the derivative of f of x here. And let me just kind of put this in a bracket, maybe a bracket would help you here, and that would be f prime of x. Okay, so there it is. There is the derivative for that function right there. Okay, let's look at question number B here. I have bracket f of x to the power 4, brackets closed, to the power of 2. Okay, so let's go ahead and take the derivative here, y prime. First of all, there's a power out there, so let's bring that 2 out to the front. So 2 bracket f of x 4 close bracket. After I do that, I want to take the derivative of the inside guy. Sorry, I want to take the derivative of this inside guy right here. So that's going to be dot f prime of x to the power 4. And then I want to take the derivative of x to the power 4, and that's going to be 4x cubed. Okay, so there's the chain rule right there. That required a few steps. And if I simplify this, I can take my constants, highlighted in blue, this 2 and that 4. So 4 times 2 would be 8. X to the power 3 times f of x to the power of 4 times f prime of x to the power of 4. And that's my final answer there. Okay, let's move on to question number C now. We're slowly getting to the end here. So another question here where you have f of x and some other notations here. So first of all, I see a 3 here. So if I do take the derivative here, I want to apply the power rule right away. So if I bring the 3 in front, that's going to be negative 9 bracket f of x squared close bracket minus 4x close bracket to the power of 2, and then the chain rule tells me that I need to take the derivative of this inside function now, and that's going to be okay, so that's going to be f prime of x squared, and if I use the chain rule here, that's going to be 2x, right? So the derivative of x squared is just 2x, minus the derivative of 4x, which is just going to be 4. And then let's just put a bracket around this whole thing here because I'm multiplying those two things together there. Okay, so yeah, I'm just asking myself, do I really want to simplify this any further, or do I just want to leave it as is? And I think I'm just going to leave it as, yeah, I think, just 1 second here. Let me think about this for a bit. Okay, so I thought about this problem a little bit more. I just paused it right there, and the only thing that I can really think about right here is I can factor out this 2, and if I factor out that 2 there, I would get 2 bracket f prime of x squared, and then the x would just be left over there minus 2. So hopefully you can see that this 4 here, if I divide that by this 2, I'll be left with that 2 there. And then if I take this 2 highlighted in blue, sorry, in purple there, and if I multiply that by this -9, I'm going to be left with -18 bracket f of x squared minus 4x, close the bracket squared times bracket f prime of x squared times x minus 2. And if you want, you could also just take this x here and just move that to the front. Variables usually come up to the front. Delete that. And I think that's probably the only way you could probably simplify this, and I'll leave it at that. Okay, so you know, this video overall took a very, very long time. It's almost an hour here. And unfortunately, like, I don't want to go over this last question here, and just to get you guys all fired up and angry here, I want this question done on your own, and please have this question ready for a homework checkoff for tomorrow. Yeah, I'm sorry, you know, I don't want to go over this last problem here, and you know, maybe you guys can just try this question on your own, and then you know, hand this question in tomorrow when I see you guys. So there it is. There's the chain rule there in video length. I do apologize that did take a long time, but you know, some of these examples here, you know, the truth is, applying the chain rule, in my opinion, is not hard. What's really hard is just simplifying your work. And I did go over, you know, all the questions, and I tried my best to simplify all the questions as much as possible, because I know that when you do attempt your homework questions, the back of the book, when you do check your answer, they're not going to give you like some difficult answer. They're going to try to give you the nicest answer possible. Okay, so please do practice simplifying your answer. All my tests and quizzes, if you're able to apply the rules, then I'll generally give you most of the marks. But you need to get in the habit of, for next year as well, to simplify your answers as much as possible, because for other problems and other word problems where you need several other steps, simplifying the problem will actually help you with all your calculations. Alright, so that's it for the chain rule. Thanks again for watching. We'll see you guys in class. Bye-bye.